Assalamu alaikum. This is 12th chemistry, and our today's lecture is about these chemical properties of these amines. As we have already discussed in our previous lecture, the basicity of the amines, where I have told you that how these basicity gets increased and how this basicity gets increased. That is the groups which increase the electron density of the of this base, and further they increase the basicity, and the groups which decrease the electron density and density that they decrease the basicity of these amines. Then we have got the another reaction, that is the reaction with acids. Now these amines, they react with acids to form salts. For example, you can see here, this is methylamine. When it is treated with HCl, it gives this methyl ammonium chloride. We can write it like this. This is CH3NH3 plus Cl minus. Then similarly we have got aniline. Now as far as this aniline is concerned, it also reacts with this with these acids like HCl to form, and this is aniline hydrogen chloride or anilinium chloride. This is the reaction of the amines with the acids. Then we have got the reaction of these amines with the metal ions. Now as far as these amines are concerned, they react with the these metal ions to form a coordination complexes. For example, like ammonia, since due to the presence of the lone pair of electrons on the nitrogen atom or this amine group, they form these complexes. As we see in case of ammonia, like ammonia, these amines combine with metal ions, like we have got silver, we have got this cuprous ions, to form the complex compounds. Now the lone pair of electrons on the NH2 group, it is used in the formation of coordinate bond. You can see here, this is a silver chloride. When it is treated with methylamine, it forms this coordination complex. This is, you can see, it is dimethylamine silver chloride. Similarly, we can call it as bis, this methylamine silver chloride. Then similarly we see, when this methylamine, it is made to react with this cuprous chloride, then it gives it forms this is tetraethylamine, this copper second chloride. It forms a coordination complex. So you can see here how the lone pairs are used in the formation of this coordinate bond. Now again, you can see in case of the here, for these methylamine molecules, they are involved in the formation of coordinate bond, in the formation of the coordinate bond. Then we have got another reaction, that is alkylation. Now as far as this alkylation is concerned, these amines, they react with alkyl halides or haloalkanes to form secondary amines, then tertiary amines, and finally they give rise to the formation of quaternary ammonium salts. This is a primary amine. You can see here, this is alkyl amine. When it is made to react with this alkyl iodide, it first one hydrogen gets substituted by this alkyl group, and it forms a secondary amine. This is dialkyl amine, secondary amine. Then it reacts with one more molecule of this alkyl iodide. Again, it loses this hydrogen atom, gets replaced by this alkyl group, and we get tertiary, this is tertiary amine or trialkyl amine. And this tertiary amine then further reacts with one more molecule of this alkyl and this alkyl iodide to give rise to the formation of quaternary ammonium salt, or we can call it as tetraalkyl ammonium iodide. Now this, as far as this reaction is concerned, it is called as exhaustive methylation. In a similar way, these aromatic amines like aniline, it also reacts with these alkyl halides to give rise to the formation of this quaternary ammonium salts. You see here, this is aniline. When it is made to react, this is methyl iodide. It gives first this it gives n-methyl aniline. You can see here, one hydrogen atom gets replaced by this alkyl group. Now this is a secondary amine, and now this is a secondary amine. Now this again reacts with another molecule of this methyl iodide, and in which we see this hydrogen atom also gets replaced by the alkyl group, and we see we get this is an dimethyl aniline. Then it reacts with one more molecule of this methyl iodide to form anilinium iodide, or it is a quaternary ammonium ammonium iodide. Then, as far as these methyl ammonium salts are concerned, they react with this moist silver oxide to form this tetramethyl ammonium hydroxide, which on heating at a temperature of 400 Kelvin, this Kelvin, it decomposes to give a tertiary amine and alcohol. You can see here, this is a quaternary ammonium salt. You can see this tetramethyl ammonium iodide. When it reacts with this moist silver oxide, it gives this tetramethyl ammonium hydroxide, and which upon heating at a temperature of 400 Kelvin, it gives this it gives this tertiary amine, that is trimethyl amine, and this alcohol. Then another reaction, one more reaction, that is reaction with these acid halides and acid anhydrides. Now, as far as these alkyl halides are concerned, these as far as these amines are concerned, they react with these acid chlorides. You can see here, this is methylamine. When it is made to react with this is acetyl chloride or ethanoyl chloride, you can see here, it gives rise to the formation of, this is n-methyl acetamide, or we can also call it as n-methyl ethanamide. Similarly, with the reaction of these amines with the acid anhydrides, you can see this is ethanoic anhydride and this is methyl amine. When it reacts with this methylamine, and this ethanoic anhydride, when they react together, they give rise to the formation of n-methyl ethanamide is again formed, and plus this acid molecule is given out. You can see here, this is ethanoic acid and this is n-methyl ethanamide. Similarly, aniline, it also reacts with this acetyl chloride or ethanoyl chloride in presence of some an organic base, like we have got this pyridine, or we can use aqueous this sodium hydroxide, and it gives rise to the formation of acetanilide, or we also call it as n-phenyl ethanamide or n-phenyl acetamide plus ACl. Then we have got one more reaction, that is benzoylation. As far as this benzoylation is concerned, these amines, they react with benzoyl chloride and benzoyl chloride both, and in this reaction we see both aliphatic as well as aromatic amines. They react in presence of some base like pyridine or aqueous and the sodium hydroxide, and they give rise to the formation of this n-alkyl benzamide. You can see this is aniline. When it is made to react with benzoyl chloride in presence of this base, this pyridine, it gives rise to the formation of, this is ethylamine. When it reacts with benzoyl chloride, it forms n-ethyl benzamide plus ACl. Similarly, aniline, when it is made to react with this benzoyl chloride, it gives n-phenyl benzamide plus ACl. Then we have got one more reaction, that is the reaction with these aldehydes. Now these amines, they react with these aldehydes to give rise to the formation of this Schiff's base. Now both aliphatic as well as aromatic primary amine. In this reaction we see primary amines react both aliphatic as well as aromatic. They react with aldehydes to form Schiff's base, or we call them as anyls. For example, this is ethylamine. When it is made to react with, this is acetaldehyde or ethanol. Now in this case, it gives rise to the formation of this, it forms a Schiff's base, or we also call it as ethylidene ethyl amine. Similarly, aniline, it also reacts with this benzaldehyde molecule, and again you can see here, it loses a molecule of water is here given out, and it forms, then this is benzyl aniline, it is a Schiff's base. So this is a well-known reaction in which we see these amines having especially these primary amines, they react with these aldehyde molecules or aldehydes to give rise to the formation of the Schiff's base. Then we have got one more well-known reaction, that is carbyl amine reaction. Now in this reaction we see both aliphatic as well as aromatic these primary amines, they react with chloroform in presence of alcoholic and this solution of this potassium hydroxide to give rise to the formation of these isocyanides or carbyl amine, which is a bad smelling compound. You can see this is ethylamine when it is made to react with chloroform in presence of this alcoholic and this potassium hydroxide, it gives ethyl isocyanide plus KCl and water. Similarly, we will then this is another this is aniline. This is an aromatic amine. When it reacts with this chloroform in presence of this alcoholic this solution of this potassium hydroxide, it gives rise to the formation of phenyl isocyanide, and then we have got plus KCl and water. As far as secondary and tertiary amines are concerned, they do not give this carbyl amine, carbyl amine, this reaction. So this reaction is used as a test for these for distinguishing for distinguishing primary, secondary, and tertiary amines, because only when these primary amines they give this they show this carbyl amine reaction. Then we have got few more reactions, and we will discuss those reactions in our next lecture. This is for today. Thank you very much.